Okay, so in this final video for doing the sums of squares the long way, we are going to calculate the total sum of squares. All right, so in the previous video, we looked at the within subject sum of squares, which is depicted here in red. We looked at the between subject sum of squares, which is depicted here in blue. And finally, we're going to look at the total sum of squares. So in order to do this, we're going to do the same kind of calculations we've done for the previous two sums of squares. We're going to get a deviation, and then we're going to square it and add them up. So for the deviation, the formula is y minus y bar t. So for each one of these scores, we're going to take the y, and we're going to subtract the y bar t. Okay, so this is 2. So 2 minus 3.5 is negative 1.5. 0 minus 3.5 is negative 3.5. 0 minus 3.5 is negative 3.5. 1 minus 3.5 is negative 2.5. And 2 minus 3.5 is negative 1.5. All right, moving down to the next group, we're going to do exactly the same thing. So we're going to take the score and subtract y bar t. So 5 minus 3.5 is 1.5. 6 minus 3.5 is 2.5. 8 minus 3.5 is 4.5. 7 minus 3.5 is 3.5. And 4 minus 3.5 is 0.5. And we're going to add these up, and it should equal 0. Just like the sum of the deviations should always be. The sum of this column should always be 0. And then last but not least, we are going to square those deviations. All right, so negative 1.5 squared is 2.25. Negative 3.5 squared is 12.25. Again, we have a 12.25. Negative 2.5 squared is 6.25. And negative 1.5 squared is 2.25. 1.5 squared again is 2.25. 2.5 squared is 6.25. 4.5 squared is 20.25. 3.5 squared is 12.25. And 0.5 squared is 0.25. I know that was fast. Feel free to pause this and do the calculations yourself just to make sure your numbers look the same as mine. Once you get, and this should be y minus y bar t squared. Sorry about that. This column is the y minus the y bar t's squared. So once you square all these, you're going to add them all up. And the sum, if we did this right, is, 76.5. 76, you can't even read that. 76.5. And this is also a sum of squares. We're going to label this sum of squares t because this is the total, or the total sum of squares. All right, so before I end this video, just a few kind of interesting points. So first of all, there's one more check that you can do, and we're going to use this moving forward. Our sum of squares a plus our sum of squares s over a should equal our sum of squares t. So let's see if that's true. Our sum of squares a here was 62.5. Our sum of squares s over a was 14. 62.5 plus 14 equals 76.5. Is that what we got for our sum of squares t? Yes, it is. So this is a good check to see if your numbers look correct. Another check that you can do, not that I necessarily expect anybody to do this, but just so you can kind of see how all these numbers work together. The within subjects deviation plus the between subjects deviation should equal the total deviation for every line in this chart. All right, so let's just take one or two of them as an example. So let's start with this guy right here. The within subjects deviation is 0. The between subjects deviation is negative 2.5. So 0 plus negative 2.5 equals the total deviation of negative 2.5. Those added up. This plus this should add this. Let's take one more. Let's take this one right here. The within subjects deviation is 2. The between subjects deviation is 2.5. 2 plus 2.5 does in fact equal 4.5. All right, so you are going to have to do a homework where you recreate this for a different data set. Again, you're going to need 9 columns, your y bar t, your y bar a, and your y. You're going to get the within subjects deviation and square it, the between subjects deviation and square it, and the total deviation and square it. It is going to be tedious. You are going to hate me by the end of the homework, but you are going to love the shortcut formula when I introduce you to it. So once you do this on the homework one time, you will never have to do it again. This will not be on an exam, but I do think it's important for you to see how we get these numbers, because otherwise the formulas are just meaningless, and we're going to move to the formulas next.